Hello, and welcome to lesson 4 in my series on waves. In this lesson we're going to be having a look at the wave equation. It's only one outcome for this lesson. We're going to be able to use v equals f lambda to solve wave speed problems. And we're going to do this by using quite a few examples. So, take the example of this wave here, and it's moving from left to right. The speed of this wave is the distance divided by the time. It's just how you would work out the speed of any object. I'm going to put a line here just to make this part easier to see. So if the wave moves to the right, you can see that it's moved a distance of one wavelength here. So if speed equals distance divided by time, we can replace the distance with a wavelength. The time that it takes for one wave to pass is also called the period, and we covered that in the previous lesson. The period is the inverse of the frequency, or 1 over f. So in the equation on the top here, we can take that t out and replace it with 1 over f. By rearranging that, we get this equation. V equals f lambda. This means that the speed of the wave can be found by multiplying the frequency by the wavelength. The first example is the most basic kind. It says a water wave has a frequency of 0.25 Hz and a wavelength of 12 meters. Calculate the wave speed. I'll let you pause the video and have a go. So if we want to use v equals f times lambda, the frequency is 0.25 Hz multiplied by a wavelength of 12 meters, and that gives us 3 meters per second. In example 2, this is a slightly more difficult one. It says a sound wave is emitted and travels through air with a frequency of 600 Hz. Calculate the wavelength. If we want to calculate the wavelength, we need to use v over f, the speed divided by the frequency. The problem is that the question doesn't give us a speed of sound. This is one of these things that you just need to know. Or, remember at the beginning of the exam paper, you're given this table here, which has the speed of sound in materials. And you can see that the speed of sound in air is 340 meters per second. We can now use these values in the equation. That's 340 divided by the 600 Hz gives us 0.57 meters. Example number 3. Again, this is a slightly more difficult one. A student watches 12 waves per minute enter a harbour. She measures each wave to be 20 meters long. Calculate the wave speed. Again, if we want to use v equals f lambda, we need to know the frequency, but the question doesn't explicitly state the frequency. However, it does say that we get 12 waves per minute, and remember the frequency is the number of waves per second. The frequency is the number of waves, 12, divided by the 60 seconds. That gives us 0.2 Hz. Now that we've calculated the frequency, we can fit that into the wave equation, v equals f lambda. That would equal the frequency, 0.2, multiplied by the wavelength, 20, to give us 4 meters per second. The last example that I'm going to cover is from the 2015 past paper. You can find it at the link on the screen. The basis of it is that there's an ultrasound pulse travelling through steel. It tells us that the speed of the ultrasound in steel is 5,200 meters per second. In the first question, it says that ultrasound pulses have a period of 4 microseconds. That's 4 times 10 to the minus 6 seconds, or 4 millionths of a second. and it asks us to show that the frequency of the ultrasound pulses is 2.5 times 10 to the 5 Hz. From our knowledge of the previous lessons in the series, the frequency is 1 divided by the period. This gives us 1 over the 4 microseconds, or 4 times 10 to the minus 6, and this gives us 2.5 times 10 to the 5 Hz. For the second question, calculate the wavelength of the ultrasound pulses in the steel sample. We're going to use lambda equals v over f, the speed divided by the frequency. Remember from the beginning of the question, the speed was 5,200 metres per second. We've also just calculated the frequency to be 2.5 times 10 to the 5 Hz. Dividing the 5,200 by the frequency will give us a wavelength of 0.02 metres. So, hopefully by now you've got a rough idea at least of how to use v equals f lambda to solve wave speed problems. Thanks very much for watching. Please like and subscribe, and I'll see you next time. Bye!